Hello everyone, this is the video lecture for Calculus 1, section 3.5, Implicit Differentiation. Implicit differentiation. That's what that says. I can't really, write very well. Obviously, you know this by now. Implicit differentiation. What does that mean? Well, it means that we're going to get started on the first problem. And I will give you exactly how this works. So I got 3x to the 7th plus y to the 5th is equal to 4x. And they say, go on, take the derivative. Try to. Y prime is equal to what? Yeah, we got an issue here right now. If you look around, it's not a y equals to start with. Generally, we have y equals, and then I can, take my derivative. That's what we've been doing for the past umpteen sections. But this time, it's different. It just kind of leaves us hanging like, all right, there you go. This is question number 1. So what do we do? What's interesting is I still don't have a good formula for you. I don't have a formula for this. But I have a method. So let's do this. I'm going to do this in 2 different methods. I called this the only wise method. That's not the official name. It's just something that I had to make up to differentiate it from my other method, which actually has a name, which is still unofficial, but it's my own. So, only wise. I guess this is the simple way, and I guess we should start the simple way. And so, let's start from the beginning. I'll show you how to take a derivative, as if you've never taken a derivative before. So first off, derivative here is very simple. The 7 comes down to the front, and we got 3 times 7, and then x to the 6, right? And so eventually we'll get 21x to the 6. This is good. We like this. No problems. Over here, I'm a little confused, but what if I do this? I'm going to take the 5 down to the front and say y to the 4th. I'm serious. That is correct. Except there's one thing missing. We need to put a y prime in there. I'll explain in just a second. And then finally, this 4x, of course, will just go to 4. Oops. My 4s don't look very good today. Any day. All right, so this is what we have right here. And let's say I still want my y prime by itself. First off, I'm going to minus the 21 whatever onto the other side. And I want to get y prime by itself, so I'm going to divide this y stuff to the other side. And so we get this is my answer. Let's talk about that most critical step one more time, from here down to here. I think that we're all okay with the power rule stuff. So when you're taking a derivative with y, it's the same as when you're taking a derivative with x. That's no problem. Our main issue is that we need to have the y prime attached to it because we took a derivative with y. So whenever we have a y, I have to say, hey, I just took a derivative with y, so I put a y prime next to it. You know what's interesting is that normally we have y equals blah, 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 and then I say, hey, take a derivative. We're always doing implicit. This is a 1, right? 1y. What's your derivative of 1x? Well, it's just 1. Or what's the derivative of 1y? It's just a 1. But remember, implicit now says, hey, I just took a derivative of y. I need to tell you, I have to remind you, y prime. And then, of course, whatever else. We're doing implicit every single time. Isn't that interesting? And that's a very cool thing to see. That's method 1. My second method is what I call the flags method. Flags. And this method is, it's more complex, and I will not be using it too often right here, at least right now in this section, perhaps even this class. But as we keep going, again, I'm assuming here that you're going to keep going to Calculus 2 and maybe to Calculus 3, we'll be doing this method a lot more. In Calculus 3 in particular, This is a lot easier than doing it the other way. So this is a good thing. It's complex for now. It's complex for now. Later on, it's going to be beautifully simple. But let's go back to what we had, and I'll show you what it is. It's very simple in the end, but I think it's a little bit more algebra. So I call it flags because whenever I think of flags, it's kind of like you're just saying, "Hey, man, this is my hill. I'm on top of this hill. I put a flag there. I just want to say this hill is mine." It's just an indicator of something. It's not actually doing something. It's not like you're actually putting people on the ground saying that this is actually my hill. I just stick a flag there and walk away, and apparently that's still my hill until somebody takes my flag away. That's, I don't know, just a common term for just a label, I guess you can say. Label. I like that. Label is pretty good. But it doesn't actually do anything. So here we go. 3 x to the 7th. The 7 comes down, so we got 21 x to the 6 dx. That's my flag. I said, hey, I took a derivative with x. I took a derivative with x. Same thing here. 5 comes down. 5 y to the 4th dy. Hey, I took a derivative with y. Just want to tell you, here's my little flag. They don't really do anything. They're just sitting there. And then, hey, what's the derivative of 4x? Well, it's 4 dx. Again, hey, look, I just want to remind you, I took a derivative with x. It doesn't really do anything right now. It just kind of sits there. But it's just reminding us that we took those derivatives. Okay. Well, how do we get to the final end here? And if you remember, dy dx is equal to y prime is equal to your derivative. Maybe you don't know that. I don't know if I said that or not. Dy dx, same as y prime. I might have put that on some kind of video along the way. I'm not really sure. But these are synonymous for one another. Again, you could also say ddx of y. You can see that you'll just get the y prime. So I know we talked about that guy, the Leibniz versus Newton method. So my goal here is going to be getting the dy over dx. And so what I want to do is get all my dx's to one side and my dy's on the other side. And so we would have the 4 dx minus 21x to the 6 dx. I'm going to factor that dx to the front. I'm sorry, that's the back. Nah, whatever. Front, back, whatever you want to put it. Sorry. And then I want dy dx. So the dx comes over here, but then this y business comes down here. And so you do get your dy dx, which is your y prime, which is now 4 minus 21x to the 6, all divided by 5y to the 4th. Ta-da! Okay, so we get the same thing. I'm guessing that you're seeing it's pretty similar, but still a little longer. And that's okay. If you like this method, cool, go with it, because I'm using it in Cal 3 all the time. But for now, I'll probably stick to the only y's method, because that's mainly what this kind of section's all about. Now, here's the last thing that's kind of strange, and I don't really like having to do this, but this is part of the answer here for some of them. So they don't like this y. They want to replace it with x's and stuff. And I only know of my original equation. And so I need to get y by itself. When I move this over, I'm going to fifth root it all. So something like that. And I can plug that in now. And so your y prime, if you want only x's, is 4 minus 21x to the 6, all divided by 5 times the, this is fifth root, that's a fourth power. So it's going to end up as the 4/5 power. And there you go. There's your answer with only x's. Now, I have that as answers occasionally. Like on the next problem here, I have the same thing. I don't remember on the homework if they force you to do this or not, but I want to show you that it is an important thing that you might need to do sometimes. So that's a good thing. This is good. I will not do it for every problem. I already see some other problems up ahead that I do not do this. And so when I don't, I don't. And when I do, I will. So there you go. Next problem. Lots of practice up ahead. Here we go. We have 7 over x minus 1 over y is equal to 3. Yeah, it's not really friendly with the fractions. What you should be doing is this. Now it's happy. So I want to take the derivative. There's a lot of times I like to actually indicate when I'm taking a derivative, like dir. And so I could put a dir step in there. dir. And so um I don't know. It's up to you. If you just keep bleeding them all together, it kind of sometimes you lose where you are. These are not in equal signs right here, by the way. That probably would work from here to there, but that's not really what we're trying to get at. It already has an equal sign, so you don't need to keep on putting equal signs. Just next line, dir. Here we go. So negative 7x and a negative 2. This negative comes to the front. Two negatives make a positive. Now to the negative 2. See, I was doing my dy again. Y prime. You can kind of think of this like a flag. I don't know. Is equal to, what's the derivative here is just 0. And so that's easier, I guess. I want y prime by itself, so move this over. I'm going to divide this to the other side. And so we got y prime is equal to negative 7x. That's going to be a positive. Positive 7x and a negative 2 divided by y to the negative 2. This is just weird. And so what you really, 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 really want instead is this guy. Notice that he has a negative power, so he belongs down here, but this has a negative power, so it belongs up there. Anyways, there you go. So that's what I have boxed in, and we're done, except that I'm guessing, because I did it again, I'm guessing they want to replace this with x's only. I almost think it's a better thing that I haven't seen the homework in quite a while, and I'm just looking at my notes, because that way I'm just giving you what math we should be doing instead of tailoring it to say, all right, everyone, on 35004, you should be definitely doing this versus that. I do that occasionally, but I just want to generalize that it's a good thing to do this sometimes too. So I'm going to take this original here, and I'm going to rewrite it. What I want to do instead is move the y's over to the other side, and then my 3 to the other side as well. And I'm going to take all this and put it in the denominator, flip it up here, so y actually equals 1 over all the stuff. That's going to be what I replace that y with right there. So then my answer should be, unsimplified, of course. Let's start over because it was really gunky. All squared, and then this guy squared. Whew. So there is actually a way to simplify this down a lot, because this guy's all in the denominator. And so I got a 7, and then I've got this 7 over x minus 3 squared, then I got an x squared, and so I could say they're both squared, and so then I got 7 over x minus 3 all times x all squared. Well, I can distribute my x, and so then I actually get just a 7 and then a 3x, and then, again, squared. And that is so much better. This is my y prime, only x's, no y's. I do not know if that's required, but it's a good practice to practice. I will not be doing that every time. X times e to the y is equal to x minus y. Implicit differentiation. It actually says it here. Well, yeah, I guess that's what we got to do. So notice that we have a product rule here. This is f and g. And so I'm going to have my f prime g plus f g prime. And so I have now x. Whoa. What's my derivative of x? Just 1. Leave the g alone. Plus, and I leave the x alone. What's the derivative of e to the y? Well, it's e to the y, right? What's the derivative? It's the same thing. But I got to have the y prime in there included. Over here, it's a lot easier. 1 and then minus 1. Y prime. Yes, that's right. You have to go and tell me whenever you're doing a derivative with y, it goes to y prime. Okay? Cool. So I got, cleaning it up, e to the y plus x e to the y prime is equal to 1 minus y prime. I want my y primes on one side, so I'm going to move this over here, move that over there. So I actually get y prime factored out as 1 plus x e to the y, and then 1 minus e to the y, divide it to the other side, and there is my final y prime answer. If you move on to higher end math classes, like differential equations and stuff like that, I do not believe you always have to go and solve for y prime. derivatives might be just good enough the way they kind of are. It kind of just depends on the class and what you're asking for and everything like that. I put a dy dx up here because I don't know why. I just thought it'd be cool. So there you go. They're synonymous anyways. Okay, next one, 35005. I've got x squared minus 14xy plus y squared is equal to 14. And we got to do this math. So I've got 2x. That was easy. Here's my product rule. Leave the 14 in the front and just work with these guys. 1y plus xy prime. I did that super fast. 2 comes down to the front, y prime, and a 14 will go to a 0. So there you go. You can distribute your 14, and that's fine. Oops, I didn't do it there, though. That's a negative 14. Make sure there's negative on both of those guys. I want my y primes on one side, so I'll just take these guys over here, I guess. So 2, and I'm going to factor out a y prime, so I'm doing about 2 steps at once here. And I'm trying to keep it looking pretty. And this is my derivative, 14y minus 2x divided by 2y minus 14x. Everything cancels! No, I'm joking. Nothing cancels. I know, it just... doesn't it look the same? Doesn't it? 35021. I got e to the x divided by y is equal to 6x minus y. Find your derivative implicitly. So derivative of e to the x is e to the x. So this you just leave alone. Oh, but I got a complicated inside. So chain rule says that I got now quotient rule, low d high minus high d low, all divided by the square of what's below. On this side, it's just 6 minus y prime is a little bit easier. If I need to get y prime by itself, which I'm imagining because that's what I just did, we got a lot of steps to go. Let's try to simplify because nothing really cancels here. I've got... Let's split this up here and distribute my denominator. I actually have a y over y squared. So it would be just 1 over y, e to the x over y. And then I've got x e to the x over y, y prime is equal to 6 minus y prime. I'm going to move this guy over and then move this one over. It really doesn't matter if you're wondering, well, which one should I use? It doesn't matter. Either way should be fine. So I'm going to minus 6 over here. I'm going to have a positive x e to the xy, y prime minus y prime. Factor these out, which often I just kind of combine into my next step anyways. So this is what I've been doing for like 5 times now. Divide this to the other side. And that's my final answer. Pretty crazy, isn't it? There you go. I have something different. I think I messed up somewhere along the way. Right here. Yep, I messed up. Hey, I admit when I messed up. Look, these guys right here made my 1 over y, right? But I needed to distribute my denominator to both of them. So this guy was attached here the entire time. I don't know if you caught that. So, hey, as I've said before, always watch to the end, see if I made a mistake. But here we go. I did, and that's okay. We can fix it. I'm going to use a different color so I remind myself what's going on here. It doesn't really change any math necessarily here because there's nothing really to do. There you go. Wow. Well, there you go, I guess. And that's why I have the answers on my notes so that I can at least verify that I'm doing it right once in a while. So sorry about that. Glad we fixed that. Moving on, next question. X to the 2/3 plus y to the 2/3 is equal to 4. I have a point at -3 square root 3 comma 1, and it's the, of course, required tangent line equation something problem. Every section's got to have this. So here we go again. derivatives, I'm going to move this down. So I got 2/3 x to the negative 1/3. Same thing here, 2/3 y to the negative 1/3. Put a y prime in there, equals 0. Derivative of 4 is just a 0. I want to get y prime by itself because that's going to be my slope. Move this over and then divide. And so I got my y prime is equal to a negative 2/3 x to the negative 1/3 divided by 2/3 y to the negative 1/3. As we've seen before, well, first off, those guys cancel. As we've seen before, you can flip these because they're both negative powers, and so it's actually going to be y to the 1/2 over x to the 1/2. They're both actually to the 1/2, so you could just do a big square root, kind of like that. As long as you know that they're both inside of the square root. Okay, that's the main thing. They're both inside of the square root. Cool. This right here is my slope. And so what I'm going to do is plug in my x and my y, okay, to get my slope. Normally we just plug in an x, but now I'm going to plug in an x and a y. So 1 over, and then I got negative square root 3 over 3. Surely I did something wrong here. Oh! I messed up again. Right here to here. What did I do? Do you see it? That's a 3, not a 2. So this is a third root. Little things, little things. Yes, so watch out because we're very accustomed to saying 1/2 and square root. This is a cube root. I messed up right there, okay? There's a 3 as well then, I guess. Oh, that's probably what it was. I had a 3 and then I wrote a 2 mistakenly. And then it just cascaded. So watch out, okay? All right. The reason why I knew something was wrong, because square root of a negative obviously won't work, but the cube root of a negative will. 2 negatives will make a positive in the end. And so I got 1 over, and then I got this cube root of 3 square root 3, which is very weird, but it is true. It is what it is. What we need to do is now reevaluate what the heck this thing is in a more simplified form, because nobody wants to do that. Okay, so what do we really have is 3 to the 1, 3 to the half, and then all this to the 1/3 power. And I want to simplify this little guy. This is, of course, all 1 over, but I'm just focusing right here, right now. And so what I could do is say, well, this on the inside is a 3/2 power, and then a 1/3. Powers of powers multiply. And so the 3's are going to cancel, leaving behind 3 to the 1/2, which is just square root 3. Again, that's 1 over the square root 3 because it's all 1 over everything like that. And so that's my slope. That's my true slope right there. We got it. Cool. Here we go. Y minus y1 is equal to m times x minus x1. So y minus 1 is equal to 1 over the square root of 3 x minus a negative 3 square root 3. 2 negatives, of course, make a positive, and when I distribute this in, it will be a little bit better. So positive. The square root 3's cancel, leave a regular old 3. Add 1 to both sides. That's what, a 4 now? Yep, that's what I got. Cool. Tangent line equation, finally done. Phew. It's always one that's required in each section, it seems. 35020. Here we go. X sine of y plus y sine of x is equal to 6. Sometimes I feel like they do this kind of stuff because it's like art. I don't think there's any applicable thing for this. Maybe there is. I don't really know. But, I mean, it looks pretty. And I wonder what the derivative is, right? You don't wonder. You just have to do it. So, so this will be implicit. But remember that this is actually 2 product rules that we have to figure out individually. And so I'm going to have this first derivative. Leave the sine alone. Leave the x alone. Derivative of sine is cosine y. But remember that we have a y prime. So I'm going to say times y prime. It's really just cosine of y and then times y prime. But I just want to stick with this right now. Okay, that's going to be good enough. And then plus, same thing over here. I'm going to take my derivative of y as a y prime. Leave the sine alone. And then plus, everything's plus apparently. Like this plus right here is this plus. But these other ones have just been created with the derivatives and whatever. And then I leave my y alone, derivative sign is a cosine, and then equals 0. 6 goes to 0. Well, there we go. I want to get my y primes by themselves, so I'm going to move this over to the other side. I'll just do this. I'm going to move these to the other side. I'm going to factor out my y primes to the front, makes it a little bit faster. So I've got x cosine of y plus sine of x is equal to, and both of these are now negative, negative y cosine x minus sine y. And then, of course, you're going to take this and divide it. Here's the thing. There's a lot of x's and y's and sines and cosines and negatives and everything like that in this problem. So just watch out as you're going through this. Make sure that you're just kind of retaining all your sines and all your cosines and all your SIGN signs and whatever else. Okay. I feel like I did this problem already. I'm looking ahead here. Yeah, I did. Sorry. Flipped the page the wrong way. Okay. I only got 2 more problems. 3, 5, 0, 2, 3. So, they say that f of x plus... let me just start over. F of x plus x squared times f of x to the 4th power, that's not a derivative, that's a power, is equal to 18. They say that f of 1 is equal to 2, and so they want to know, what is f prime at 1? What? Right? Okay, let's just pause. I just want to stretch a little bit because what do we do? What do we do? I'll tell you. I know you're waiting. Your f of x is actually equal to y. And so, what if you were to just do this instead? Is that something you've seen in this section before? Yeah? Okay. Well, then let's do it. Derivative. I haven't been following my little dir rule, but whatever. Y prime. Product rule. 2x y to the 4th plus x squared 4x squared y cubed y prime equals 0. I was simplifying just a tiny bit. Just a tiny bit. Not a lot. Just a tiny bit. Y prime 4x squared y cubed y prime is now equal to moving this guy over. Factor this out to the front. I mean, there's nothing new here. Nothing new here. As soon as I said, oh, f of x is the same as y, it should have just went, oh, and then you could just do the rest of the math because nothing here has changed. And that is okay. Ta-da! What? That's not right? It is right. It is right. What they want is the actual value. Like, they want a number when x is equal to 1. Here's the funny thing. So x equals 1. Cool. But look right here. X equals 1, and what is y equal to? It's 2. And so what I actually have here is my point, 1, 2, that I can plug in everywhere. So here we go. 1, 2, oops, to the 4th. And then I have 1 plus 4. That's a 1. That's a 2. And that is definitely a calculator. And I got negative 32 over 33, and that is correct. Calculator good. Calculator good. Last problem. So, x squared plus 6y squared is equal to 6. And they say find y double prime. Now this is going to be tricky. Now, yeah, we're in Calculus 1, we're in Chapter 3, we're not doing a great deal of heavy math right now. So this cannot be that complicated. But, as going forward, they will have this some more, and it will be complicated. Be on your guard. 2x 12y, y prime is equal to 0. Move this over and divide. Pretty straightforward. And so what I have here now is negative 2x over 12y. And you can simplify a little bit because guess what? We're going to need to simplify to be able to figure this thing out. Okay, so what I did, this is what I did. I just took the derivative using quotient rule at this point. And I do recommend it. I do recommend that. I don't recommend trying to solve for only x's. Do you remember we were doing that, right? Let's go back for a second. No, I mean way back. Way back. Right here. So, like, if you were seeing that we had x's and y's, but then I went a step further, what's your derivative with y's in it? I don't know. What's your derivative with just x's? Oh, I could do that. So my point is that in the past, whenever possible, I've tried to solve for x and x alone so that I can actually get my next derivative easily. So now we're back here. And I need to figure out what this derivative is. Well, if I can get y by itself, it should be a little bit better. So I move all the things over. I got a square root of y, and I plug it in, and that's going to be a big square root down here. Yes, it is possible. No, it is not friendly. And so what I want to do is do it the different way. I want to do it a different way. So here we go. Y prime goes to y double prime. I'm doing implicit differentiation on this guy as well. Yes. That is a true statement right there. Anyways, so y double prime. This is my actual derivative. You ready? So I need to take a derivative of this guy. Remember, this can be a high and a low, and so we're going to do some quotient rules. So low d high minus high d low divided by the square of what's below. Oh my goodness, here we go. 6y, derivative of this guy's going to be a negative 1. Negative x. What's the derivative of this guy? Well, it's 6 y prime. Yeah, what's the derivative of y? Well, it's y prime. And then divided by the 6y squared now. So is this your answer right here? Is this your answer? Yeah, kinda. But here's your problem. Here, I'll show it to you. It's right here. You can't really do that in WebAssign as far as I know. And so what you're actually going to have to do is plug this in. This is y prime. Yep, that's a positive x here, and then that's a 6. Let me just put the 6 in the front, 6x. And then now we have a negative x over 6y that I just plugged in, and I got 6y both squared. You could definitely simplify this guy a lot. Blah, 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 math, and apparently this is your answer right here. I didn't do any steps. I just somehow magically got to it, so there you go. But it was still fun getting there, and that's the point of math, right? Just to have fun. That's all I got. Thank you very much. Have a great day.